Okay, what we're going to be talking about today is Lesson 6-1, Rate of Change. The rate at which a quantity changes can be determined either by computation, using your math, or also by looking at a graph. And we're going to look at both things as well as using a spreadsheet to determine the rate of change. An example here, they have, what is rate of change? Mr. and Mrs. Overjoyed had a healthy baby girl named Joy, who weighed 7.5 pounds at birth. At the end of 4 months, the baby weighed 13.5 pounds. How fast did her weight change from the birth to 4 months? To answer this question, we calculate the rate of change of Joy's weight. That is how much she gained per month. So if we look at from 0 to 4 months, what we're going to calculate is the change in weight divided by the change in age. Okay? If you notice, they start with the 4-month weight. Okay? So 13.5 pounds is what she ended up at, minus 7.5 pounds is where she started at, is equal to 6 pounds. At the end of our study, at 4 months, she was at 13.5 pounds. So 4 months minus the beginning age, which is 0 months. 4 minus 0 equals 4. If you take 6 divided by 4, you get 1.5 pounds per month. So she gained 1.5 pounds every month. It says at 6 months, Joy weighed 15.75 pounds. How fast did she grow from 4 months to 6 months? Use the same method to calculate the rate of change in her weight per month from 4 months to 6 months. So we're going to use change in weight divided by the change in age. Okay? So at 6 months, she weighed 15.75 pounds. We subtract 13.5 pounds, which is where she was at 4 months. 15.75 minus 13.5 is equal to 2.25 pounds. 6 months minus 4 months is equal to 2 months. So 2.25 pounds divided by 2 months is equal to 1.125 pounds per month. So as you can see, from 0 to 4 months, she gained more weight each month during that time period than she did during the 4 to 6 months time period, which should seem natural because a baby quite early is going to gain some weight or gain their weight back after they have been born. Looking at data and trying to determine which rate of change is greater or less greater, we can look at this graph of the baby weight and the age. Age is the X value, body weight is the Y value. It says these data points have been plotted at the right and connected to make a line graph. The rate of change measures how fast the graph goes up or down when reading from left to right. Since Joy's rate of change was greater from 0 to 4 month period, here's 0 to 4 month period, it has a steeper incline than from 4 to 6 months. If you look here, this is a greater slope than from 4 to 6 months. Why is that? Well, because she gained more weight each month here than she did from 4 to 6 months. You're going to hear me a lot over the course of this chapter that the rate of change is the change in the Y values divided by the change in the X values. Your change in Y values divided by your change in X values. And we're going to look more about that once we get to our spreadsheet. Negative rates of change. Joy was gaining weight, so the rate of change was positive. But a rate of change can also be negative. We're going to look at population. We all know population can increase and it can decrease. If you follow your basic mathematical rules that we have shown you, you're going to be able to tell which is negative, which is positive. If you look at example 1, The population of Chicago from 1830 to 2000 is shown in the table on the next slide. Find the rate of change of the population of Chicago in people per year during the given time period, and describe how the rate is pictured on the graph. So we're going to look from 1890 to 1900. So here's 1890, here's 1900. If you notice from 1890 to 1900, there is an increase in people. So what we should be looking for is a positive rate of change. Okay? If you look at this graph, 1890 would be about right here, 1900 here. If you notice, the graph's going up, so we should be looking for a positive rate of change. So, following the model that we just did, we're going to look at these 2 points, okay, 1890 and so forth. You're going to write down those 2 points. I'm going to write those down real quick. 1890 and 1,099,850, and 1900 is 1,698,575. Okay. So let's do a little math here. Here's my 2 points. Okay. If you notice, this is just a coordinate point. This is my x value. This is my y value. This is my x value. This is my y value. Okay? What we're going to do, as I said before, it's the change in y divided by the change in x. Okay? So, we're going to take this point minus this point. So, 1,698,575 minus 1,099,850 divided by my change in x values, 1900 minus 1890. Notice, I went from the 1900 minus the 1890, okay? You go to the furthest in the time minus the least amount of time. So that's going to equal, if we get our calculator out, $1,698,575 subtract 1,099,850. What I'm going to get is 598,725. Now, we all should know 1900 minus 1890 is 10. If I'm going to find out people per year, dividing by 10 is moving the decimal point 1 unit to the left. So what I'm going to get is 59,872.5 people per year, and that's positive. So we know each year from 1890 to 1900, we gained approximately 59,872 people per year in Chicago. Looking at the next question here, 1970 to 1980. So we're going to check that time slot. Once again, I'm going to write down those 2 points. 1970 comma 3,999,850 369,357. In 1980, 3,005,072. What you should notice, this number's bigger than this number. Therefore, your rate of change is going to be negative. Okay? Your rate of change is going to be negative. Let's see if it looks the same on the map or on the graph. We go to 1970, which is going to be about right here, down to 1980. Yeah, it's going down, so my rate of change should be negative. Let's do our math. So, once again, x value, y value. X value, y value. I'm going to take this and subtract it from this. So, my change in y's, 3,005,072. Subtract 3,369,357. Divided by 1980 minus 1970. We all know that's 10 at the denominator. We want to find out what the numerator is. So on my calculator, 3,005,072. Subtract 3,369,357 equals, notice it's a negative. Don't forget to put that negative sign in there. Negative 364,285. Once again, move the decimal point 1 unit to the left. And that's going to equal a negative 36,428.5 people per year. So what that means is in Chicago during that time period, 1970 to 1980, Chicago lost approximately 36,428 people every single year during that decade. When you read graphs in algebra, you read them from left to right just as if you would read a line from a book. A positive rate of change indicates that the graph slants upwards. A negative rate of change indicates that the graph slants downwards. Rate of change. Rate of change between points x1, y1 and x2, y2, those are just two random points, is, as I said, change in y's over the change in x values. So y2 minus y1 all over x2 minus x1. And you need to get used to that formula because it's the same formula you use for slope. So you need to start thinking about that. Because every rate of change comes from division, the unit of a rate of change is a rate unit. So in example 1, a number of people is divided by the number of years. So our unit rate was people per year, written as people divided by year, or people / year, as you saw me write as well. Calculating rate of change on a spreadsheet. Similar process. You have your x values here. You have your y values here. This is my years. This was my population once again. Here's your years. Here's your population. X values, y values. As you can see, I put over here. Same process. Change in y values divided by the change in x values. So, 29,963 minus 4,470 divided by 1850 minus 1840 equals 25,493 divided by 10. When we divide that by 10, we get out 2,549.3 people per year. Okay? That means from 1840 to 1850, the city of Chicago gained 2,549 people per year. A zero rate of change. Sometimes quantities do not change over a certain interval. You think about population of Rockford. Over a course of a month, their population probably doesn't change that much, if even at all, or over a course of several years. When you have a rate of change that does not change over a certain interval, then what you have is a rate of change of 0. Okay? Example 2. The table below shows estimated attendance by the hour of a professional baseball game that went into extra innings. A says, during what time did the attendance not change? Well, if you look from 1 to 2, it went from 1,200 to 18,000, so we know it changed there. From 2 p.m. to 3 p.m., it went from 18,400 to 23,200. Once again, it changed. The attendance grew. From 3 o'clock to 4 o'clock, if you notice, we still have the same population. So that did not change. If you look from 4 to 5, once again, attendance did not change. From 5 to 6, it did change. So we would say, during what interval did the attendance not change? We would say from 3 o'clock to 5 o'clock. If you look at B, find the rate of change of the attendance during that time. Well, we're hoping it comes out to 0. Once again, these are my x values, so I'm going to use 3, 23,200. And I'm going to use the point 5, 23,200. Once again, change in y's over the change in x values. So it's 23,200 minus 23,200. I know everybody's probably thinking it's obvious, but I just want to show you how you can show that we have 0 rate of change. 5 minus 3. Well, 23,200 minus 23,200 is going to give you 0. 5 minus 3 is 2. 0 divided by 2, obviously, is 0 people per hour. So our attendance did not grow or decrease during those 2 hours. Okay? Taking a look at this graph, and it's a very important graph. You're going to want to mark this and write this down in your notes. But if you look at this, rate of change, when you have rate of change that is positive, what you have is a line that goes upwards from left to right. Notice this line going upwards from left to right. You have positive slope. When you have a rate of change that is negative, that means you have a downward slant, which means your line is going to go down from left to right, as in this case. If you have a rate of change that has no change, that means your rate of change is 0. What you have is a horizontal line. A horizontal line is a flat line going left to right. Thank you very much. To Tomorrow we'll go over questions out of your book or off your worksheet, and hope you're going to enjoy this Flipping the Classroom.